Relations and functions. I don't think you're going to find this section to be too hard to get through. By the way, a lot of students find Chapter 2 much easier than Chapter 1. So, okay, so relations, any set of ordered pairs we can call a relation. The domain's a set of inputs, the first coordinate, the x values, whereas the range is a set of outputs, the second coordinate in the ordered pair, the y values. And so the domain of a function, if you're looking at the graph, is how far left to right it goes. And the range of a function, if you're looking at its graph, is how far up and down it goes. And then a function is a type of relation where no two ordered pairs have the same first coordinate and different second coordinates. So to be a function, each input has to have one and only one output. So for our examples down here, if you work 6 hours, you get paid $64. You work 8 hours, you get paid $64. If you work 10 hours, you get paid $64. That is still a function because each input has only one output, even though the same output has different inputs. Whereas over here, if you work 5 hours and one day you get paid $60, and the next day you work 5 hours and get paid $100, that's not a function because the input, the original value we're starting with, produced two different outputs. Functions can be described by equations in two variables, the independent variable, the dependent variable. The dependent variable is a function of the independent variable, and again we commonly refer to x as being the independent variable and y as being the dependent variable, though certainly we can use other variables, other letters to represent those variables. Function notation, f of x, it looks like f times x. It does not mean f times x. It just means f is a function of x, and it's just a fancy name for y. So if we have a function f of x equals 2x plus 3, we can evaluate the function using function notation. So f of 2 is shorthand for saying let x equal 2, plug it into the function, and then evaluate to find the output. So if we're looking at f of 2, we're replacing x with 2, and so we replace this value of x with 2 also. Get 2 times 2 plus 3, giving us f of 2 equals 7. F of 0, we're letting x equal 0. So we replace the x with 0, replace the x with 0, simplify, and get the output. So it's just a nice compact shorthand notation. Here's the input, here's the output. Here's an input of 0, an output of 3, an input of -3, an output of -3. Generally, we assume the domain of a function will be all real numbers whose result will be a real number. So things we're watching out for at this point are dividing by 0 and square roots and negatives. There's other things we need to watch out for, but those are the main things at this point in the course. And there's also some functions where you're modeling situations, so story problems where only certain values make sense. Like in some story problems, negative values don't make sense, and so they're not part of the domain of the function. So looking at some different functions, here we've got a nice simple linear function. There's no values that we could put in for x that will not give us a number back out. So we're not dividing by x's, we're not taking square roots of x's. Any real number times 2 plus 3 is still a real number, so the domain is all real numbers, which you can describe as being the interval from negative infinity to infinity. For this function over here, g of x equals 3 divided by x subtract 6. What we're going to worry about here is we do not want x to equal 6, because that would give us a 0 in the denominator and the function would be undefined. So different ways we can say that. Simply x is not equal to 6, or we could say the interval from negative infinity to 6, not including 6, and then the interval for values bigger than 6 to infinity. Or a little more formally with the set notation, the set of all x such that x does not equal 6. And then with the square root function here, with square roots we're worried about taking square roots of negatives. So whatever's inside the square root we want to be greater than or equal to 0. Equal to 0 is okay, the square root of 0 is still 0 and that's still a real number. We can solve for x. And if you look at it graphically, what you'll see is that the function will stop when x is at 1.5. And so the domain we're talking about, the values of x, the horizontal movement of the graph. So it starts at 1.5 and goes to infinity. Okay, the vertical line test is something most students remember from previous algebra classes. If you're looking at a graph of a function, and any vertical line you draw will only intersect it once, then you know you have a function. Whereas if you have, say, this graph of a circle, if we draw a vertical line, we intersect the graph in two different points, and that is not a function. because we have one input having two different outputs. Increasing, decreasing, and constant intervals of a function, again, it's pretty visual. Just remember, when we're talking about this, we're always talking about the x values. So you want to be looking at the graph from left to right. With this parabola, looking at it from left to right, we can see the function's first decreasing, then increasing. And so when we describe the intervals where it's increasing and decreasing, we're always describing it in terms of x. So this function is decreasing for x values from negative infinity up until it hits 2. And then it's increasing for x values from 2 to infinity. This is kind of a funky looking function here. It's still a function because it passes a vertical line test. And it's increasing from negative infinity until we get to x equals 0. Between 0 and 4 it's a constant function, and then from 4 to infinity it's increasing again. So just look at it from left to right, focus on the x values. And this is something we're going to come back to again later on in the term, but we'll take a quick look at it now, and that's a one-to-one function. So again, for a function, each input has only one output, but for a one-to-one function, we also want each output to have only one input. So use a vertical line test to see if we have a function, and then we can use a horizontal line test to determine if we have a one-to-one function. So this is the function of f of x equals x cubed, and it's a one-to-one function. Passes both the vertical line test and the horizontal line test. Whereas a parabola here, y equals x squared, is a factor function because it passes the vertical line test, but it's not one of the special cases of being a one-to-one function because one output has two different inputs. It fails the horizontal line test.